Empowering seamless, secure learning for education from kindergarten through college.
Thank you very much. I appreciate it. Hello, everybody. I'm the field CTO for HPE Networking, specifically for higher education. I've had a lot of history in the industry. I've not only been in networking for almost 50 years, but also have been in direct contact with C-levels, CTOs, CIOs across the world when it comes to higher education. And it's been a great ride. Starting from the Juniper side of things all the way to where I'm at. I was an adjunct professor for over 40 years in the system, so I know what it's like to be on both sides of the fence when it comes to education. This presentation is one of the ones I love doing because it is making such a dramatic change in how we look at networking. People don't realize that there is such a dramatic change that has happened over the last 10 years and what has caused it, what's going on today in terms of as you're making your selections on what you're going to do, how you're going to transform your networks. HPE is there. So I do take care of the higher ed side as well as the research and education network community. So Cenic, for example, one of our great partners and doing some wonderful things in research and 800 gig networking that we do with them, as well as academic medical centers across the country. So to kind of get you started, I just want to make sure you understand when I talk about networking, it's not about boxes. It's never about boxes. It's really about the experience of somebody on a network and how do you justify what you're doing on the network to make them feel good about what's going on. How do you know when somebody is happy with what you're doing, right? A lot of times it just can be just a simple Yelp review that says, oh my gosh, the Wi-Fi stinks on campus, and you didn't even know. You thought everything was working just fine. So for me, it is about transforming the network. It's talking about the fact that where I'm talking from comes from a place where I've seen dramatic change over the last 8 years, tremendous change, to the point where now the top 10 universities in the world are all doing the solution that I'm talking to you about, which is to incur and use AI and how we take AI and to incorporate it into what they're doing. And I'm going to explain a little bit deeper what I mean by that, because it's important to understand that all AI is not created equal. It's not the same as I'm going to go to ChatGPT and ask a question. This is about understanding the experience of individuals over time and understanding how that affects the learning of an individual, whether it's a student in kindergarten all the way up to college graduates. So we've experienced a lot of good things in this world in terms of the growth. It's been double digits, very much growing and replacing what's out there, transforming networks, not just upgrading or refreshing, let's call it that. When I talk to folks, I really want you to understand that I care about, and what we care about, isn't the box you buy. It's about the student's experience. The student's experience specifically on how you can keep them into classes, right? When I talk to CTOs and CIOs all over the world, they say their number one thing is student retention, right? How do I keep a student in class from the time they're a freshman to the time they graduate? How do I make sure that they're progressing? How can I ensure the safety of that student on campus? How does my network do that? Or how can it do that? Right? So when you look at those things, at the same time, I work with lots of R1s and R2s. The number one thing that they worry about is how do I keep nation states from stealing my proprietary property? How do I ensure that security is in such a way in a network that I can keep and make sure that I'm keeping not only just the attacks that can happen, the things that, that can be introduced into a network by a student who's doing something he shouldn't, but also how can I protect it exterior? It has to be endemic in everything that you build into a network. And the same thing is, you also have to say, well, to manage all of this, how can I make it simpler? Because the way we've done networking has not been simple, right? If you wanted to go if you were trying to diagnose network problems, what do you have to do? You have to have a big expensive certification that allows you to find a needle in a haystack looking for that little thing to fix it, to find out why it's broken, and it's to fix a box. As opposed to saying, I know I have a problem because these individuals have issues and here's why it's happening to them. At the same time, when you're looking at what you put into a network, it should be more than just getting on the network. It should provide a platform for you to do other things in the network. Right? And I'll explain what I mean by that in a minute, but it should be able to do more than just getting on Netflix, for example. And then for R1s and R2s, how do I look at the data center? How can I look at research? And for example, we have a solution that utilizes AI and AI-driven approach to being able to replace InfiniBand using Ethernet as the key component there. So a lot of the things that we've been doing, like here at Cenic, where with the 800 gig solutions that we've been doing, deal with that. Now, having said that, that's not technically what I'm going to talk about today. It's all about the fact that we're talking about transforming the network. These are, if you go to the best global universities ranking, go to US News and World Report and look at the top 10, what are you going to see? You're going to see that HPE is the solution, especially for campus and branch. It's the #1 solution. So whether it's Harvard University that does Aruba, whether it's Massachusetts Institute of Technology that does HPE Juniper, we own this marketplace. HPE owns higher education as a structure across the globe, and there's a reason why. It's because we took a look at things. So this is an example of a quote from Jim Molesky, who is the CTO over at the University of Massachusetts Amherst. He had a problem. His issue about a couple of years ago was simple. I have a problem that every time my students move from class to class during class periods, the Wi-Fi just crashed. And again, the reason why it crashed was because of architecture, how it was built. It was built the old way. I call it, you're gonna hear me use the term, the anti-AI method, right? But it caused chaos. Here we've got a quote from Jason Hardy at UT Arlington. He's the VP of infrastructure. And he tells me, he goes, man, I never realized how at risk my network was to a device going down to where the chancellor was calling me going, what the heck is going on? That I lost a box and now I've lost the campus, right? And so the network is critical, not only just for the quality of the education you're doing, but it's the transport that keeps the lifeblood of what needs to happen in education going all day long. So the thing I want to start with is to let you know this. #1, it is really important to understand that just because a light is green on a box, it doesn't mean it's working. It doesn't mean you have a great experience, right? I've been there. I've been sitting there where I've taught a class, for example, and suddenly, and it would be a hybrid class, so I had people in class, but I would also have screen like this, and suddenly it would go wacky, right? Things would happen. Maybe they couldn't hear me. Well, that's a bad experience. However, everybody's telling me the network's up. I don't know what's wrong. So what ends up being, if you're a network guy trying to fix something, your whole goal is to have what I call the mean time to innocence be seconds, not days. Mean time to innocence means I can tell you what's wrong before you tell me that it's wrong. That's the real goal in networking, right? So having said this, I'm telling you this because this is how networking worked. We had to take a different approach to how we deal with networks. And this is what all these universities that I'm talking about, where we have over 1,000 some networks now, have gone to what I'm going to talk to you about to replace what they had in the past, because they knew that something had to be done that was different in the approach. The approach shouldn't be fix a box, it should be fix your experience. And that's where AI comes in. It's very important. So as an ex-engineer, I used to be an engineer before they lobotomized me, put me in sales, and told me to take customers to lunch. For me, I used to deal with this all the time. When you look at trouble ticketing, for example, right? If somebody just made one call and said to you, oh my gosh, I don't like the Wi-Fi, that would set off a chain of events, a ton of events that you'd have to sit there and look at and say, what's going on? 11111, check them off the list, come out. Would you do me a favor and come out and meet me at the place? What's the worst thing you could do as an IT organization to a user on your network? To drag them into your troubleshooting process. That shouldn't happen. It should never happen. But this architecture, and the reason why these architectures I'm talking about that were built in the 90s, that was the old way. This is what you had to do. So think about how long just one of these takes. If you can eliminate just one trouble ticket, how much time it would save you, right? It's not going to be because you have a certification on a box to go fix it. It's going to be because you're going to have tools that are AI-driven that understand the problem before you can do it. So when you look at this, there's architectures that have been created. So go all the way back to the 1990s. Remember those days? That's the days of the BlackBerry. Would anybody use a BlackBerry phone today to do all the stuff we do? Probably not. Although I did see one. Someone came up and said, hey, I still have a BlackBerry. But, it had a very useful function at the time, but it's not there. The problem you have is this architecture, and it's not built for AI. When something is not built for AI, you're not going to have the ability to do anything that's transformational because you're just keeping the lights on. In this particular case, the old architecture, and I'm going to focus for just a second on wired and wireless networking, okay? Wired and wireless networking is the core of what you get on campus for the most part. It's what students see when they first come on campus. It's your main interaction with the university in a lot of cases. The way that it was built before is you'd have all the access points in wireless up on the roof, and you drag a cable all the way back to a data center and you put in controllers. And then for those, you have to have, and when you have enough controllers, you have to have master controllers. So you have this stack level of equipment, all just to get on the internet. All of it controlled by a monolithic piece of controller software. This one big piece of software scares everybody to death because you're afraid to upgrade it, because it's the same software that was started in 1990 something, right? It's just been tacked on and fixed and patched and whatever. And so we've had situations where universities have come in, where the students came in, and you can go look it up on EDUCAUSE, that they came into class for the very first time in the fall, and the network was down for 2 weeks because somebody did the controller upgrade. Because this architecture here is fragile to the point where if you break something, you may break something else, but if it breaks, it takes you down hard. So something had to change in terms of how you look at the network. In addition, when you look at this network, you say to yourself, what else about it? Well, if I would like to do network management, guess what? In a lot of cases, you got to put in sidecars, right? Injection points into your network. A whole extra architecture that has to work with this monolithic software that if it changes, it could break it. What if you want to do things like location services, where now you're thinking, and again, I'm not talking about just the menu popping up on my phone, but actually having real use cases where the location of what your device is so important to how you learn that you can understand it because it's there. In the old days, you had to go buy battery-operated beacons. I always like to talk about the story when I went out to the VA Medical Center, who has completely transformed their network. The VA Medical Center down in Florida, they had a situation where when I first walked in, they had all these little tiny dots on the wall, Bluetooth beacons. They had literally over 3,000 of them. 3,000 beacons. And that was to try to do something with location services. And it worked wonderfully for 6 months. What happened in 6 months? You had to replace 3,000 batteries. And so that became untenable to the point where it says, why can't I just build an architecture that can accommodate all of this at one time? So you've got this stuff, where you saw speed changes in wireless, for example, was only speed, but no architectural changes. If you change something, it could break a million things. That monolithic software model had to go. It has to be replaced by AI. And so what I like to talk about is the paradigm shift in networking. There is truly a paradigm shift that has happened in networking. Now, just to define for you paradigm shifts, for those of you that might be wondering how I look at it, if you were to go and want to watch a movie today, how many people here run over to our good friends at Blockbuster and go rent a VHS cassette? None of us, right? Do we go to Netflix and order the DVD to be sent so I can watch it and I can put it back in the envelope? We don't do that either, right? Do we run to Walmart and go buy the DVD? No. What do? We stream it, because the cloud enabled something very different. Now we have changed. We had a paradigm shift in how you consume entertainment. That paradigm shift was functioned by the cloud, which again, now take that same thought about that transformational force and put it into networking. How can networking change to the point that this paradigm shift will now be the same as how you looked at networking before to how you look at networking today? So what I want to talk to you about is a proof. Now, as an adjunct professor, I should be able to prove to you why I say there's a paradigm shift. And by the way, HPE has delivered on it, has been the actual focal point of where this thing has changed. So are you familiar with Gartner Group? I think I had some cards all passed out. So if you know who Gartner is, right? They're one of the preeminent consulting firms that deal with the very fact of what is happening technologically from year to year to year, and they will give you something called the Magic Quadrant. There's 4 quadrants, and you want to be in the upper right because that's where everybody should be. They're telling you this is where it's at. So if you move in a chart on Gartner more than just an inch up, down, left, or right, you've made a big difference. Something has happened. If you make a big change, you've actually punched the poor consultant in the head to say, look, there is something so different going on. I need to understand why and what changed, right? And so I always like to talk about this. And so this particular chart is the wired and wireless Gartner Magic Quadrant for networking. And this is important to look at because you look at where we were, Juniper Networks, Juniper Networks was, and a company called Mist Systems, we were down at the bottom. Would anybody have chosen us in 2018? Probably not, because back then this is what you bought. You bought controllers, you bought master controllers, you did all that stuff, and you bought lots of equipment, and you had a lot of people that were specifically built around fixing boxes, right? So at this point, Juniper actually bought the company called Mist Systems. Why is that important? Not because we felt Mist had the best Wi-Fi, because they were they were a spinoff and a startup that was really focused on Wi-Fi, but we didn't buy them for that. That was not why Juniper took on Mist. It was because of the architecture, the change that we envisioned and we saw that said when we bought Mist, it was because they looked at things differently. They said, let's tear up the paper. Let's stop doing it the way we were doing it. Let's look at experience of the person. Let's look at AI. And that is what we wanted because we knew that at that point that we could take AI that was being done on the Wi-Fi side and put it into switching. And now put it into security, and now put it into routing, and now put it into data center. So that progression is important. So when we first did this, we moved up a little bit. It was significant in terms of Gartner because nobody moves that much, like I said, in 2019. But look what happened in 2020. By 2020, Juniper was now number 1 in the ability to execute. That meant that Gartner went, whoa, nobody moves that far in 1 year, okay? And there's a reason why this change has happened because it started to go away from the old architecture I talked about to where now in 2021, Juniper was the undisputed leader. Only our sister company, now Aruba, who was moving in the same directions we were, which is why they stayed kind of close to us here. Everybody else is moving out, but this is what's going on. You see it's there to the point now when you look at where, if you got the one card, you'll see we are number 1, have been number 1, way far out. Look where Juniper shows up on this chart now. At the same time, look who's not on the Magic Quadrant. I won't point it out, but you can look at it and you can see there's a reason why, because some vendors cling to the old architecture and they're going to try to band-aid things by saying, oh, I've got agentic AI and see, so I've caught up in a day. It just doesn't happen. This never happens. So you look at this, you had 4 years in a row where Juniper was the very top. You had Aruba that's been in the Magic Quadrant for 19 years. Now, in the purchase of the 2 companies coming together, which is very important because not only is it going to vault everything on the Aruba side and the Mist side, we're all going to move to the right even further to show you that if you're making any solution choices and thinking about this. So I'm going to set the stage of what's different. I need you to understand what's different about networking and how AI comes into play here because that's what it is. It's the student experience for me, how it got affected by AI and things like this. And so the key to everything we did, we ripped up the paper and we said, instead of doing what we're doing with this obese software and equipment in the data center, everything should instead be through a microservices cloud architecture. There's a lot of things here I just read to you. Microservices cloud, what the heck is that? So microservices is different, where you had the monolithic software, where it's all one big piece of software. Here, everything is a slice. Your interaction to the network as to your personal experience in the network goes up through this cloud. The slices are the individual pieces that can be updated every day. So for example, there's a thing called radio resource management. Radio resource management is the ability for like a Wi-Fi 6 access point to say, hey, I'm right next to another one, quit talking so loud on this channel, and to have it dynamically change. Well, that's a piece of the architecture that's just a slice. And so when we fix that little slice, guess what? You get it immediately. You don't have to worry about it. You don't have to schedule downtime. It's because the microservices cloud gives you that ability. Number two, the big ability for the microservices cloud is to allow us to accumulate data from multiple sources. So it's not just me trying to find a problem on my network. It's not anything like that. It's actually me in a cloud where the specific data about my experience, not about payload, so there's no security issues here. This is about understanding what is going on in the network. And so, for example, in the Wi-Fi world, there are 150 pre and post data points that are sent to the cloud every minute of every day about your personal experience on the network. That's phenomenal because it goes up to the cloud, goes over, it's done, it goes into our machine learning and data lake, it's churned, and then if we find something that's new, everybody gets it. Because in this cloud is not only Stanford, it's not only UT Arlington, UT Dallas, or Dartmouth, or Oxford, or Reading. It's everybody. It's Walmart's 800,000 access points, and their entire wired and wireless switching architecture is all in there, all going up at the same time, where we can do the AI machine learning thing on the back end to create and understand what's going on when we find a problem. It's how we found out that in the Amazon world, when we were first trying to do Amazon 5 or 6 years ago, we put it in, and it went in literally an hour. We put in a proof of concept, and on a Friday, we told them by Friday afternoon, hey, did you know you're missing like 7 VLANs? To which they came back to us, and said, he goes, no, we're Amazon. We don't miss VLANs. They came back on Monday. What did you think they found? 7 missing VLANs. And that's, I mean, again, we didn't have to go, what's wrong with the network? It told us, you got these VLANs are missing. Your experience for these people are not going to be good when they go from building to building, and that VLAN is not on that switch. So that's what this shared infrastructure gives you. And keep in mind that when I talk about this, it's that what is important to Wi-Fi when it comes to AI and the information that goes up is different than what is going on with a switch. So a switch, we call it mystification. To be able to say, I want to be able to have the AI agents working on the switch to say, hey, I'm on a hardwired switch. How do I track what's important there? It's going to be different than what is going on in a security world. It's going to be different than what happens in the data center, and it's going to be different than what happens in routing. And so for us, instead of, when folks, I look at them, they piecemeal solutions, I'll buy the wire here, wires, this. They're really costing themselves, because if you have an infrastructure that has been built for Wi-Fi, or built for AI, we call it being AI native. It's an AI native agent that's going to run, that's very specific to that equipment. So all of that is built around this microservices cloud. So it gives you the ability to accumulate lots of information in disparate ways. When we came together with Aruba, it was very important to understand this is why our competition tried to stop us for so long. Because when you look at this combination of things, Aruba was really good at working on what we call agentic AI. That's the self-driving part of AI. Versus microservices architecture and an AI native approach, which is using AI agents to be very specific, to find things that are very specific about what's going on in the network, right? So agentic AI is the ability to kind of accumulate all that and be able to make it into what we call self-driving. And that's the goal. That's the goal of what you should have in networking, is to have a self-driving network. And this is the path that you're going to see. So when you look at this, and again, most of our competitors, just so you know, are at stage 2 where you get these insights. But if you think about where we've gone in the world of AI and self-driving networks, it started with cars with sensors, right? You get a little beep that tells you, hey, you got a problem in your right tire, you better fill it. It gave you basically data, and that's it. But you had to go figure out what else was wrong with it. Stage 2 is where you start getting insights. That's like driver assistance, right? Where you say, hey, I'm going to go and I'm going to turn on my cruise control and just go at a certain rate. So I'm just traveling at 55. no matter what happens. And if I'm going 55 and the car's going 44 in front of me, I'm going to run up on the back of them, right? But it's giving you insights. It's telling you, here's I'm going this fast, and here's where I'm going. That's where most of the other competition. That's when they talk about AI or self-driving. That's where they are. Then you have adaptive cruise control. Does anybody have adaptive? Don't you love it to be able to lock onto the bumper of the person in front of you, and if they speed up and you've got a maximum set, it'll kind of go as far as that will go, but if they slow down, it'll slow down. You don't have to think about it. That's what we call stage 3, the recommendations part of a self-driving network. Then you get into stage 4, where it's proactive remediation, where the ability to now look at it from the standpoint of controlled self-driving. And so like my Tacoma, I'm driving, and if I happen to be not paying attention, if I bump off the side, I come right back on. And so that's kind of where between 4 and 5 is where we've been. And now that we have agentic AI, we're moving into the self-driving world to say, if I've got a problem, why can't I fix it? If a router has a busted route, why can't it fix it? If the Wi-Fi is having an issue that's caused because of a missing VLAN, why can't you fix it? Now, I will say, I haven't had the pleasure of driving in a Waymo. I was in a Tesla that was turned in self-driving mode. I can't say I always want to do it that way. I should have the choice. I should have the choice to do what I want, right? And so that's what I'm telling you here, is that you do have that choice. And the way we look at networking, you should say, you know what, if it's an IoT device and it's connected to a camera, and a camera does its famous thing of freezing. Anybody seen an IoT camera freeze? What do you have to do? Got to get up on a ladder and push a button or unplug it or whatever? Instead, to be able to say to the access point, hey, if you see this and you see traffic stop, why don't you dynamically do it on its own and just tell me you did it? Save me that having to even worry about it. Well, that's what that is. And so that's where we're at in this path to the self-driving network. I will tell you that our companies like ServiceNow that are also on our platform now for the very specific purpose. They will tell you that they reduced their operational expenses by over 70%. Their trouble tickets were over 90%. Dartmouth College will tell you they dropped their trouble tickets by 95%. This isn't marketecture. This isn't marketing literature. This is real. You can call people and you can ask them. I can have you talk to Brian Doherty at UT Dallas, who told me just 2 or 3 weeks ago that he was able to take his people supporting wireless from 4 people down to 1. Did he let go of 3 people? No, because every university is so stretched, we can use these people doing other things than just keeping the lights on, right? And so to go from 4 to 1, think about that. That's a story that will go from over and over and over that I can tell. The universities that have adopted this will all tell you this same story. So if the college is looking to do something dramatic in terms of saving expense, this is how you do it. We're working very hard on this cross-pollination. When you talk about this whole merger, people always say mergers can be a disaster. This has been the most wonderful merger that I've ever seen, because in our world of cross-pollination between Mist and Aruba, you're going to see an access point that can boot into either or, and you can see our stuff in Aruba Central. You're going to see that HPE is your main solution for doing this in terms of how we do it. Now, I've got about 2 minutes left, and so I'm going to skip a slide here and go directly into one other thing on location services, because I want you to understand that a network should be more than just a network. I would like it to be able to do other things. And so when you look at how you do these solutions, like the Bluetooth thing I told you about, it's siloed. Its use cases are very limited. You gotta go do your own stuff. It's closed, and you hate to change batteries if you can help it. Versus an AI native approach to it, where we say, we have a standards-based platform that you can build on and do things that are pretty neat. And so when you look at that, what can you get out of a HPE network? We have all these neat sources. I call it 5+1 sources of location contacts, because remember that 150 pre and post data points? We also have in here an engine. You see that little device at the bottom there? That's a 14 antenna array whose purpose in life is to provide precision down to 1 to 3 meters of every device in the network if you want it, in the same network that you already put in. 80% of what you need for a full location services thing is built into the network itself because that's there. And we can look at it from BLE mobile app tagging. We can look at not only just tag-based, but it can be on the mobile app itself. It can be passive listening to BLE devices, Wi-Fi connected users, or even Wi-Fi unconnected users. You're able to see all of that information. But the best part is now we've just updated it to include ultra-wideband. So again, a wonderful way of looking at it. So I know I'm going to be out of time here, so I just want to finish on this slide on the built-in location services that you get and how this also affects your students' ability. So it's not only the AI I talked about, but it's the ability to have wayfinding services. We had a university that built their own wayfinding application, Blue Dot Navigation, for a new student coming on campus for the first time, experiencing the campus for the first time in a way that they could not do in any other place. Makes the student be very ready to go. MIT did contact tracing during COVID. We have the roll call integration with our partners like Seat Software and Critical Arc that can do student retention increases by 30% by just understanding the nature of where we're going. So the two things I wanted to bring across here is you can see how this all impacts the student experience. Students get smarter, they stay in class longer, you're able to do this, but so it's not only just about the quality of the network, it's about the other things that you can do as well. And again, keep in mind that ultimately all the other things I talk about, as you look at an architecture, everything should be AI native, and that's where we are. We're in that world of where you're going to be able to be getting to a self-driving network. The last thing I will say, and I'll shut up, is everything here is something we can show you in a minute. If you want to do a proof of concept, just reach out to the sales team that's here, and they will set you up. And I guarantee you that if you just give us 48 hours to get on to do something, because that's how long it took, you'll be able to see something you've never seen. Once you've seen it, you won't be able to unsee it. Because when you see how AI works and how it saves your life and how it finds your problems for you, you will never want to go back. And so that's what I wanted to make sure. So student experience, that's what it's about. Do I have any questions, any things about this that you might want to have me answer? Yes?
What do you do with somebody trying to inject maliciously into the AI that's evaluating the network? That seems like a weak point of the network as a whole.
So in the world of AI, at least when you talk about AI agents, it's the device, they won't be able to get into the device to inject it, number one. So keep in mind that all the things that we're doing is we're taking the telemetry data or whatever, it goes up into the cloud and comes over and comes down. You can't inject that as a user and say, hey, I'm going to, what malicious things can you inject? Because when you talk about something that's AI native, an AI agent, not necessarily the ChatGPT agentic side of things, and the AI agent is very controlled. Its purpose in life is only to look at certain things and in a data lake that gives you tremendous insights into what's going on based on that, just the telemetry that you're getting, because you have to have the right data that you're selecting, and so it's going to reject everything else. I hope that answers your question, but there's really not a way to do it. And that's why also in all of this cloud infrastructure, you should want somebody that's NIST certified, that's GovRAMP certified, that's StateRAMP certified, all of which verify that the cloud is secure from that perspective. Okay? Any other questions? Yes?
I don't know if you mentioned this already, but what changes with like the topology of setting things up at different campuses? Can you speak to that perhaps?
Yeah, so when we talk about how we set things up, okay, so again, architecture matters. In the old days of having you saw that big architecture where you got the controllers and all that stuff. You don't have to have all that equipment. By the way, the same thing goes for network access control. We do this too. We've completely changed how we do network access control, where it's all in the cloud and it works with Edgerome and all those kind of things as well. But the idea is if the architecture is built in such a way that the device communicates directly to the cloud, it's a simple thing. So I'll give you an example. Dartmouth College, 2,000 access points for their dorms. 2,000, okay? How long do you think it would take in an architectural world to go put it in? Months, right? Maybe a whole semester? I don't know. How about 48 hours? 2,000 access points in 48 hours because of the nature. What they did is they took students, they gave them the access point, they went into the dorm, they unclicked the Cisco, threw it in the bin, and then clicked in the same bracket, the missed access point. Took a QR code picture, bink, plugged it into the Ethernet, it was up in a minute. Nobody can do that. This is how Walmart does it too. I mean, so that kind of architectural change, it frees you. That's what gives you the scalability that I'm talking about, because it's very easy. Everything's in independent pieces. As far as in the core parts of the network, somewhat similar. You have to make choices on what you're going to do. But again, having the network, the switches itself, they should be something you look at in terms of whether you're going to do spanning tree versus EVP and VXLAN. But if you're going to do EVP and VXLAN, let's make it simple and have an AI way of looking at world. We call it Abstra, where we can say, here's how I want to design it. Here's how it got put in. Did I put it in the same way I thought? And architecturally, it will create the fabric for you, even in a third-party environment. So between that, same thing goes for network access control, where you get rid of all that devices down here and you put it up into the cloud, and now you got access to all your authentication devices up here, whether it's Microsoft, it's Azure, whatever, but it's all there. Instead of having to say every time I move from building to building to building, what do I have to do? I have to go and say this guy can go here, this guy can go here. Oh, they moved, and it's just waiting for a disaster to happen. Control into the network is now injected. It has to be a part, it has to be endemic. And so security itself has to be something that is built into every single device, and it needs to be zero trust. So architecturally, it is zero trust, and this is where I talk a lot about that when I have a whole session on security about how we deal with that. Because if it doesn't start with zero trust at every device, again, router, switch, again, if you're buying it from another vendor, pieces of here and there, you're not going to get the full value of being able to look at something as a family where you have a single pane of glass to be able to look at it and control everything. Again, seeing is believing. So put me to the test. Give us, whatever your worst building is, you call me, and we'll come up with a way to do a proof of concept for you, and I guarantee you will like what you see. Any other questions?
There's time for more questions if you guys have other questions. No?
Steve.
So could you talk a little bit about the architecture and the cloud and really the demarcation points? It seems to me as there's also a movement with AI into the edge. I've got AI right here. I don't need to go to the cloud. And latency becomes an issue. It seems to me that the demarcs are in a period of flux as we're trying to design the network optimized for AI. Can you speak to that?
Yeah, so basically what you're kind of leading to receive is more about what I call agentic AI, where you're trying to look at data lakes. In our specific case, the internet is only the connection to the cloud for us to get to the data lake that we're doing. In an AI native world, it's agents that are very, and again, you can't, one of the presentations I do on wide area networking is about inference and where you do AI inferencing. Well, you can't cache AI inferencing, because that's why people are building these humongous data centers, because that inferencing has to happen there. And so you do have to have a faster WAN, which we did. That's why Cenic is doing the 800 gig WAN they're doing, to be able to do this kind of inferencing for those kind of data pieces. So that inferencing that you're talking about, for us, there's almost no problem with it. And in fact, if you lose the internet, like there's some networks that say, hey, I'm in the cloud too, or I have AI too, but what they've done is they've taken that controller architecture and put it in the cloud, and if you break the connection to the network, what happened to your network? You're dead. In our case, you can lose the cloud and the inferencing stuff, but your network will still run at wire speed and whatever it's doing, because it doesn't necessarily need the cloud to work. Does that make sense, right? I know we're over, but any other last questions? Okay, I'm here. If you want to talk more, I'm always glad to talk. I appreciate your time. Thank you very much for the opportunity to speak. Hope this has been interest to you all. All right? Thank you.